My name is Mike McReynolds. I'm the production manager at Atlas Carbon here in Gillette, Wyoming, and we produce activated carbon from coal. So activated carbon, just background on what it is, activated carbon. Activated carbon is a type of carbon that is a result of thermo or chemical processing. Potential feedstocks, that's a little hard to see, I apologize for that. Potential feedstocks are coal, nut shells like walnuts in particular, coconut, petroleum coke, or wood, and our feedstock is coal. Activated carbon is defined by its very large surface area, extremely large surface area. 1 gram of activated carbon can have more surface area than a tennis court. In particular, our activated carbon that we produce here in Gillette, we have a surface area of 450 meters squared per gram. A tennis court has a surface area of 260 meters squared per gram. So in a pinch of activated carbon that we produce here has more surface area than a tennis court. Some activated carbon, some of the really high-end activated carbons can have upwards of 3,000 meters squared per gram, which is more than a football field. So it's tremendous amounts of surface area, and that surface area is then used for chemical absorption. That's what all that surface area does. It traps these chemicals and particulates. Our Atlas product has excellent vapor phase mercury absorption characteristics. That's our main focus right now. Mercury capture for power plants in the vapor phase. How it works, there's two basic legs to how activated carbon works. It's all about porosity and particle size. Porosity are cavities or pores carrying varying sizes that serve to act as selective sieves to trap molecules of a desired type and size range. In particular, we're talking about micropores. Those are what we're focused on, are micropores. Now, these micropores are 0 to 2 nanometers in width. And for those of you that don't really know what a nanometer is, it's 1/1000th of a meter. So 1/1000th of a meter. It's incredibly small. And that's what we're focused on. That's the best thing that we have found that influences vapor phase mercury capture. That's what we're focused on. The other part of how activated carbon works is particle size, and this influences the dispersion of the carbon in the flue ducts in the power plants. So finer particle size gets better dispersion, more contact with the mercury, better capture. We accomplish this with a fine grinding down to less than 20 microns, and this improves the activated carbon performance. Kind of an industry standard is about 20 microns. Our milling process, we take it down to 10 microns. So better dispersion, lots of micropores. We have good performance so far in the tests that we've done. Marketplace for activated carbon. There's two major marketplaces that are being attacked by activated carbon right now that we're focused on. The first is vapor phase, the second is liquid phase. Vapor phase in particular relates to the mercury air toxic standards, the MATS rules that we heard about previously. The 1990 Clean Air Act finalized a rule in 2011, influences coal burning power plants, cement kilns, and industrial incinerators. This is what we're focused on, mercury capture. Vapor phase also has a market in petrochemical refining, volatile organic compound controls in manufacturing plants, consumer retail products, solvent recovery, chemical purification, and other industrial filtration processes. We're even starting to get some interest from the oil and gas industry on capture of propanes and VOCs from their flaring operations. So instead of flaring off all these very high BTU gases, they can capture it on activated carbon and repressurize that system and get those compounds to come back off. So instead of money going up in flames, we can resell those vapors, and that's starting to be looked at. In the liquid phase, the water treatment market represents the second largest outlet for activated carbon, with demand in drinking water treatment and wastewater treatment. There are new regulations in the United States and worldwide. Sales of activated carbon in the drinking water market are forecast to expand 8.9% annually to 364,500 metric tons in 2016, and this growth is not expected to decline. It's only expected to increase and get better. So we see this as kind of the next step in our evolution as Atlas is focusing on the liquid phase. Powdered activated carbon PAC is used slightly more often in drinking water than granular activated carbon, also known as GAC. The reason for this is its low price combined with its ability to filter out a variety of chemicals as well as its disposability. However, granular activated carbon, which is more like I guess a fine beach sand, or it can even be pelletized. It's used with its ability to be reused. You can actually regenerate these carbons once they've been used up, and there's a whole side process, a whole side industry to activated carbon production where plants take these used carbons, reheat them, regenerate them, and then resell them. So market share, as a pie chart, we're focused right here on the industrial side, 32% of the market. We would like to be in the water treatment side in the very near future, and like I said, this is 28% now, but it's increasing. Food and beverage processing at 24%, pharmaceutical and medical 5%, with other markets also at 5%, and motor vehicle at 6%. Now this is mostly wood-based carbons, not coal-based carbons, because wood-based carbons are really good at absorbing petrochemicals, but then also releasing them, which is important in vehicle applications because it allows the engine to take these vapors back off and reuse them. Coal carbons that we make, they're great at capturing chemicals, but they don't like releasing them, which is great for mercury capture, but not very good for motor vehicle applications. So retail products, you've seen all these, I'm sure, wandering through the store. We've got the Brita filter, the HVAC filter, toothpaste, body wash, deodorant, face cream. There are numerous activated carbon retail products that are for sale right now. And again, this market is only increasing and it's only going to expand. PAC producers in the United States. There are only really 4 or 5 activated carbon producers in the United States right now. Calgon out in Kentucky, ADA in Louisiana, Norit in Texas, Norit up in Canada, and Atlas Carbon here in the United States. That's what all of these bubbles with labels are. These other small dots indicate activated carbon regeneration facilities. These are usually located close to municipal wastewater treatment plants, in particular California, so Los Angeles, San Francisco, Phoenix, Dallas, Chicago, Detroit, New York, Philadelphia, and Pennsylvania. They take these carbons, they reheat them, regenerate them, and then resell them for use. And usually they don't resell them for, from my understanding, for wastewater use. Once they're using wastewater, they can resell them for vapor phase use, and we've seen some of that. The yellow arrows indicate import sites for carbon coming from overseas, and there's quite a bit of carbon that's being produced overseas. Australia, Indonesia, Germany are some of the sites that are producing activated carbon overseas right now. Looking at this map, one thing that stands out is most of the carbon is being produced in the southern and eastern United States, either regenerated or virgin production. There's a big hole right here. And that's why Atlas chose Gillette, Wyoming for its site for activated carbon, because we think that based on our location here, just based on transportation costs, we can cause a market disruption by being located in Gillette, Wyoming. We can cause, we have better transportation value to Montana, Idaho, Utah, Colorado, Nebraska, and we've tested at some of these sites and had good success. And we think that we can really drive down our cost and put a strain on some of these other producers that have to ship either over the road or by rail. Transportation costs can add 1 cent per pound for every 100 miles of over-the-road costs. So if you're looking at a one-day travel over the road for 65-cent carbon, which is kind of the market average right now in industrial use, you could add 10% of your cost just by trucking it. That doesn't make sense for these guys. It makes a lot of sense for us. We're within 100 miles or even 200 miles of a lot of power plants right here, especially in the state of Wyoming, Colorado, Nebraska, and Montana. We've even tested down in Arizona. We're getting a lot of interest down in Arizona right now as well. So carbon basics, the technology for producing activated carbon. Carbon's been around for a long time. The initial production was with rotary kiln. This is just a big barrel that rotates. It's got a blowtorch on one end, feedstock comes in the other. The heat drives the vapors off the carbon. You're left with just the heat drives the vapors off the feedstock, whether that's coal, coconut, what have you, and leaves carbon. So heat comes this way, feedstock comes this way, carbon drops out the end, vapors go out the top. It's called countercurrent flow. Similar type of process with the multi-hearth furnace came about in the 1940s. These are big vertical heat stacks, basically. There's different levels of heat with big rotating arms that stir the feedstock. There's different levels of heat, so as the carbon drops down, it heats up a little more, vapors get driven off. Again, countercurrent flow. These processes take hours and hours of stirring, lots of mechanics. You can see how big, here's a man for scale, how big this rotary kiln is, how big these multi-hearth furnaces are. They're huge. Process takes a long time, a lot of heat up time, a lot of feedstock, a lot of time to process it and get it out of there. By comparison, this is our pneumatic flash calciner, our PFC. This is a picture of our plant right now. The reactor is right here. It's a 40-foot tall stainless steel cylinder with a natural gas-fired blowtorch in the bottom of it. And our process takes seconds, literally seconds. It takes about 2.5 seconds from the time coal enters the reactor to the time it leaves the reactor at the top. Very fast. We have about 2 to 2.5 hours of warm-up time, and then we're ready to make carbon. Really fast, and the advantage to that, that quickness of warm-up time as well as variability is we can vary different things throughout our reaction train and have quick response time, whether that's temperature, inputs, water inputs, steam inputs, air-gas ratio. We can vary a lot of different things and have instant response and not have to wait hours to see what that carbon looks like. So we're very nimble and very responsive to not only things that we want to see, but also customer demands. We can tailor carbon if they want to have, for instance, a really low kind of microporosity carbon, something on the order of 200 micropores. We can run it really fast through there, not give it as much heat. Or if they want really high micropores, we'll run it real slow through there, give it a lot more heat. We can tailor our product to what the customer wants. So the pneumatic flash calciner takes feedstock coal to a very high temperature at a rapid rate. We're talking from ambient temperature, whatever our silo is, call it 65 degrees. We take it up to 1700 to 1900 degrees Fahrenheit in the matter of seconds, and it popcorns the coal, blows it apart. We have low operating costs, a small physical footprint, a short warm-up time, and low maintenance requirements. We also have high consistent quality and a uniform activated carbon product. The rapid processing time gives us the system flexibility to adjust to different specifications of feedstock coal as well as customer inputs. So a simplified process description, our licensed technology can be divided into two main categories. Our carbonaceous feed material, either coal, coconut, nutshells, any type of organic product. Our calcination, so devolatilization and activation, blowing that coal apart. Process gas conditioning, so those volatiles come off the coal and are processed and emitted as vapors. And then post-activation treatment, which is our milling, and what we like to call beneficiation. So we can actually add different products to our carbon to help oxidize the mercury and help the carbon capture the mercury a little bit better. We call that beneficiation. So we can sell unbrominated product or brominated product, depending on the customer needs. These are scanning electron micrographs of carbon, and you can see it's a little difficult with the black and white, but you can see the fractures right here, and there's holes in here, and these are the micropores. And these micropores go in and they wind around. We like to compare it to a bramble thicket. It's real easy for a contaminant like mercury to get in. It's really, really hard for it to come back out. And so this is the close-up picture of what activated carbon looks like. Lots and lots of pores. So our company, quick summary, Atlas Carbon was founded in 2014. We have a proprietary patented process. In June of 2015, we were granted an environmental permit from WDEQ. In January of 2016, we completed construction on our initial production line. We have tested at numerous power plants using Atlas activated carbon injection equipment with Atlas produced activated carbon and have successfully maintained compliance in every one of those applications. We've also shipped test product to power plants in Wyoming, Arizona, and Nebraska, and have gotten good feedback from all of those sites as well. Our Wyoming permit will allow expansion of our production to an annual output of 108 million pounds of activated carbon. Our Fort Union plant, which is on North Garner Lake Road in between Wyandotte and Dry Fork. We have 20 acres of property on the Fort Union Park complex. Co-located with the plant is 5,000 square feet of office space and approximately 10,000 square feet of shop space. Production line 1, we are rating it at 16 million pounds of annual production. Subsequent lines are planned in 16 million pound increments of activated carbon production per year, which will bring our total annual production to 108 million pounds. We have road and rail transportation access as a rail loop that goes through our industrial park that we would love to take advantage of and ship rail cars of carbon out at some point in the future. Our primary coal feedstock supplier is Eagle Butte. They're with 3 miles away from our plant, and we have additional 5 Powder River Basin coal mines within 20-mile radius of the plant. That's the reason that we're in Gillette, because of our access to coal. Coal is our feedstock. It's what we think is the best feedstock because you don't have to process it. When you have coconuts or lignites or walnut shells, a lot of these multi-hearth furnaces or rotary kilns, they have to do chemical treatments to get the rest of the I guess undesirables away from the carbon. They want to get that all the way down to carbon before they heat it up because they don't want that heat to be wasted on other things that aren't going to have those micropores. Coal, it already has that. Mother Nature did the hard part for us. It already baked all those everything off. It's left with organics. 72% or more of our coal is carbon, and so it's the best feedstock. That's why we're here, and we're planning to stay here. The company was granted a minor source emissions permit from WDEQ in June of 2015, and we are permitted to produce up to 108 million pounds of carbon per year. With our expansion, we have applied for the Wyoming Large Loan Fund through the Wyoming Business Council, being voted on by SLIB today. That's a $25 million large business loan that we want to use to expand our business. Right now we employ about 15 people here in Gillette. Coal consumption is about 30,000 tons, and we think we can produce about 16 million pounds of activated carbon. We want to expand up to 25 to 32 people, 90,000 tons of coal consumed, 48 million pounds of carbon produced. This is a picture of our Fort Union plant. We repurposed a lot of the existing infrastructure that was left from the Fort Union mine. These silos right here, as well as these transfer belts, were all left over from the mine. We use those for coal conveyance right now. We have a truck dump right here that we get the coal from Eagle Butte. It's run through a primary crusher, up a transfer belt, up another transfer belt to this silo. We can store as much coal as we need in that concrete silo. From there, it's pneumatically conveyed to this silo, which is our granular coal silo. And from there, it's again pneumatically conveyed through our reactor, which is, again, right here. It's 40 foot tall by 5 feet wide, real small footprint. Goes through our heat exchanger to cool the carbon down. And at this point, once the coal is impacted with the heat, the processed gas is driven off, and we have concurrent flow as opposed to countercurrent flow like the other system. So we have concurrent flow of gases and carbon come into a product collector where the carbon is separated from the processed gases. The processed gases are taken to an oxidizer, which is hidden back here behind this infrastructure. It's heated up. All those volatiles are heated up and driven to carbon monoxide, NOx, SO2, which is then emitted from the stack under our WDEQ permit. This is our only emissions point right here. Very clean. We don't have any particulates. All the particulates are captured right here in our product collector because our particulates are carbon. We don't have any particulate emissions. Particulates, the carbon come into this quality control silo where we test the carbon for our different internal specs as well as industry specs, ash, moisture content, as well as particle size and surface area. From there, if they meet quality control specs, we send them either to this large silo, which can store 6 million pounds of carbon, We can send it to a truck loadout, which is back over here, or we can send it to our mill, which is located in this building, where we further can mill it down and send it to the truck loadout or other storage sites. Some other pictures of our Fort Union plant. This is inside our milling building. This is our bromide salt addition infrastructure. Our pneumatic bulk tanker truck. This is how we ship all our product. Well, I guess I shouldn't say all. The majority of our product is via bulk pneumatic container. We can also ship via super sacks. This is a green storage silo. The reactor is right back here. Again, granular coal silo, QC silo, product collector right in there. This is the control board. This is it. This is what controls our plant. One man, and it's this particular screen right here that runs the whole show. Very, very small footprint, very easy to control. One guy in one spot. This is some of the lab toys I get to play with. This is our surface area analyzer. It allows us to test and qualify our activated carbon on surface area. So I was told it's one of the only ones, if not the only one in the state of Wyoming, that we are one of the only ones that can do that with that machine. So coal as a feedstock, like I said, we like coal as a feedstock. Other feedstocks that are out there, coconut, lignite, and wood. We like coal because it has a high incidence of micropores, decent amount of mesopores, which are more important for the water phase capture, because there's a lot of larger particles in water pollutants that aren't really, basically, they're too big to fit in the micropores. So the mesopores are really where they're captured. We're not real great on mesopores right now, but it's something we think that we have a beat on and can get to. But like I said, we're focused on vapor phase. We want to be high in micropores right now. Coconut is kind of the best vapor phase. They've got fantastic micropores. They're some of the best out there as far as activated carbon. But most of this comes from overseas. This is all locally produced here with our coal from Gillette. This is some comparative testing data that we've done with carbons that have been produced from different coals, and it's a little difficult to see. This is Louisiana lignite. These are all Atlas in this column. These are some competitors: Norit, Calgon, ADA, and HOK, which is a German coal. So Louisiana lignite, North Dakota lignite, Louisiana lignite, PRBs. Norit uses a Texas lignite. Calgon uses a bituminous coal from Kentucky. ADA uses a lignite down in Louisiana. Looking at micropores, which is this column right here that we're focused on, Calgon is kind of the industry standard. They're the best. They have been for 70 years. They make a lot of carbon. They're the ones you've heard about. Their micropores are 785. I mean, they're fantastic. We're not too bad. We're right kind of in the middle. We're comparable to Norit. We're actually a little bit better than Norit, and as well as ADA. We've got micropores in the 3 to 4 to 500 range that we've produced with different types of coal. You know, it's not just PRB coal that we can use. Our process is transferable to different types of feedstocks, but PRB coal, based on its other properties, is very attractive for us. It heats up uniformly. It produces a great, uniform, consistent carbon, and the quality is right where we want to be. And so we, just looking at the different competitors that have a head start as far as experience, money, market share, yeah, they're good, but boy, we're right in there. We're real competitive with everybody else. Coal has a feedstock. We're the only non-combustion value adder. We don't burn the coal. The majority of this coal, the coal that's mined in this county, goes to power plants, is burned up, and its use is as a thermal stock. We take that coal and we transfer it we turn it into something that's more valuable than it was when we received it. So we get coal at approximately $10 a ton, so 0.5 of a cent per pound. We sell that for 65 cents a pound, roughly. This is an unbrominated cost, and that is $1,300 per ton. So we take a $10 per ton feedstock, turn it into a $1,300 per ton product. These are real numbers. I mean, these are actual real numbers, and we have 4-to-1 coal to carbon consumption ratio. And that's that's something that we like to focus on. This price is kind of an industry standard. If you get some of the higher carbons, they could sell for anywhere from 80 to 90 cents a pound. If they're brominated, they might be a little more. But this is kind of a market benchmark for unbrominated right now. And that's it. Any questions?
We like the margins, so that's good.
Us too.
Going back to the conversion rate, and you talked about 4 to 1, and I remember an earlier slide, there was about 90,000 tons of coal will yield roughly 24,000 tons of activated carbon, so that's about 4 to 1. And you talked about some of the vapors get vented. So do you have information about how that 90 million tons, where's the other,
It's the gases.
It's just gases.
The stuff that makes the coal burn, that's what's going away. And we put that through the oxidizer, and it comes out as CO2. A lot of it's moisture. 30% of coal is moisture. It's got 30% water vapor on it. So only 70% of the actual coal solid mass is reacting. The rest of it is water. And
there's no other solids that you have to deal with?
No, we don't have any waste. Our only waste is gas. It goes out the stack. We don't have any solid waste. We don't have any liquid waste. Our only waste is, well, we have a lot of waste heat. We generate a lot of heat, and we're looking into different ways to use that heat, whether it's preheating the coal, possibly to help oxidize it initially, or there's even been talk of getting an electrical generator and starting to generate some of our own electricity on site using some of this waste heat. So we would like to have zero waste at some point, and we're working towards that.
I get devolatilization.
Yeah.
What is activation?
Activation means it's tough to define. Active means that it has high absorptive capacity, so that's the surface area. A real active carbon has a lot of surface area. So activation is the same similar process to devolatilization. So it's not just driving those volatiles off, but also freeing up those micropores, causing those micropores to crack and pop, and causing the actual solid structure of the carbon to popcorn and create those micropores and fractures.
And what sort of total U.S. market is there out there for activated carbon? This is a new product to me.
Yeah, you know what? I don't know. I know that Colstrip up in Montana, they have 8 million pounds per year usage. Let's see, Wyandotte here uses approximately 2 million pounds of carbon. I don't know the total market pounds per year usage, but as far as the vapor phase, it's huge. The water market is really big too. The trouble with the water market is so spaced out because municipal water facilities, they don't generally use a lot of activated carbon, but there's a lot of cities. There's a lot more cities in muni water plants than there are power plants. So the water market is tremendous. And that doesn't even touch on the retail market, which is even bigger than that.
Hey, Mike, thanks. Here, you mentioned about very, very little waste, but do you have to deal with ash disposal or removing the ash, or does that just goes in with the product?
The ash is part of the carbon. We sell the ash for 65 cents a pound, just like we sell the carbon. Okay. The ash is internal. So no, we don't have any solid waste product. No ash.
Okay. What's that? Yeah.
No, that's lignite. Yep, that's lignite from Texas and Louisiana. Yep, that's correct. Yep.
Could you describe your ownership?
Yeah, our ownership right now, we're completely 100% privately owned. We have one main investor. Our home office is in Louisiana, New Orleans, Louisiana. We have an investment board of, I think, 4 or 5 people. We're all privately owned right now, and we're applying for that Wyoming State large loan. But we would like to remain privately owned for the foreseeable future. But yeah, that's it's all private equity right now. All right, thank you.